Today, we will show you as many as 16 tricks and experiments with water. Let's take markers for a whiteboard and any smooth surface. Let's draw something. I'll have a little man on a raft. Now, gradually pour water into a bowl and pattern separates from the surface begins to flow. Just look at it. The little man on the raft seems to be really rocking on the waves. And you can also pick up all this paint with your fingers, like some kind of threads. Let's repeat this trick with such a spiral. Coming off the surface, the threads begin to get confused. But by picking up one of the ends, we can all pull the whole thread out of the water. And if you put your hand to such a drawing on the water, it will remain on your skin. Let's try with one more complicated drawing. Lower the web into the basin of the water, put your hand under it, and smoothly pull it out of the water. Here you have a tattoo. We hit the neck of a glass bottle with the hammer and the bottom immediately flies out. And here's what would happen with sparkling water. The first blow, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, and only for the ninth time the bottle gives in. Why is that? It's all about gases. If the drink is carbonated, then before the pressure pushes out of the bottom of the bottle, it must first get rid of all the gases in the liquid. Unlike ordinary water, and here are the consequences of our experiment. Empty the aluminum can, boil the water in the kettle, and fill the empty jar with the outgoing steam. Now we throw it into cold water and it instantly collapses. And the difference in pressure is to blame for everything. Now we light a gas on the stove and heat the spoon. Then add a few drops of water and see what happens. It's like they're dancing. Let's take a bigger volume. The frying pan is very hot. We start adding water to it like a lot of crystal balls. And if you start rocking the pan, the drops will unite into a single stream and begin to rotate around the perimeter like a ring. Just look how beautiful it is. An ordinary glass of water. Let's pour it out a little. Now we take a piece of newspaper and attach it to the glass. Turn it over, hold it for a bit, and voila! The water does not pour out. Do you want to know what the secret is? Keep watching the video. Let's take a plastic pipe and rub it thoroughly with the rag for the appearance of static electricity. Let's bring it to the water jet and see what happens. The water is attracted to the pipe. Let's take a plastic water bottle. We'll hang it over an open fire. And now, let's speed up the video 70 times. As you can see, the plastic bottle does not burn and does not even melt despite contact with fire. But the water inside gradually begins to boil. But the higher the water the temperature, the more deformed the bottle. Let's take it off the fire and make some tea. If you put one end of the rope in an empty cup and the other in a cup of water and lift it into the air, then the water will gradually begin to flow along the rope from one end to the other. All the water is now in the bottom glass. Let's put ping pong balls in two identical containers. One will contain water, the other just air. And now look at how differently the balls behave under water pressure and under air pressure. Let's take just half a glass of absorbent and see how much water it can absorb. Fill the first liter and remove the swollen absorbent. Then the next jug and so on until all the powder is gone. In total, as many as 9 liters came out. But how much absorbent has increased? Take a paper clip and use another paper clip to place it on the surface of hot water. Then another one, then a pin, then a hairpin, and a needle. They begin to be attracted to each other. Let's take something heavier, like a knife blade or a steel ruler. But they still stay on the water. Even if you just throw her, she still won't drown. It's all about the surface tension on the water. But a light blow to the vessel will immediately send them to the bottom. Now, we need an upward pointing hose that beats like a fountain and a foam ball. We'll leave it on a jet of water and it stays in the air. Unbelievable! It's time for a bigger ball. Let's throw him on the jet and see how he keeps on it. In slow motion, you can see how the ball rotates around its axis, spraying water. It is thanks to this that the ball is held on the jet, and even if you interrupt the flow for a second, the ball will still return to its position. Here's such an unusual trick. Let's see how many drops of water will fit on the coin. We will add them with the pipette smoothly and carefully. Incredibly, a whole 41 drops fit on the coin. This is very important. Take a plastic bag full of water and pierce it through with the pencil. Surprisingly, the water does not pour out. No matter how many pencils I stick in, let's not be petty and use all the pencils we have. There's no living space left in the package, but the water's still inside. We will put several glasses of water in a row, and we will install glasses with paint on top of them. Push the first glass and they all fall like dominoes into their own glass. Attach the hose to a subwoofer, turn it on, and then the water. With the help of a phone or a computer, we will set the sound with the appropriate decibels and watch something incredible happen to the water. It looks as if the water is twisted into a spiral and drawn back into the hose. When changing decibels, the water will continue to change its shape and direction in a bizarre way. But at the same time, it retains its all-liquid properties. Look, you can wash your head under it. Do you want to know what the secret is? Watch our next video. So, what's the secret of the glass trick? In a plastic mug, which we put under the newspaper and inserted into glasses? Well then, he held on thanks to the surface tension of the water. Just a slide of the hand and a little physics.